Guys, an example in chapter 9, I was asked to explain. Particular, I think it's example number 5. So let's go to the Ask My Instructor link. And this is an interesting problem involving a technique of including a categorical variable to account for an event. In this case, every 4 months or so, a new chip is introduced. But first, I want you to do something which is easier said than done, and that is to pick the proper chart that corresponds to this data. So let's look at the data. This is the demand, the thing we're trying to predict, and this is a month number. And we see that as the months go for higher and higher, the company is doing more and more business. I guess as the economy is expanding, whether advertising is working or a whole bunch of other factors. But every now and then, every 4 months or so, they introduce a new chip. So let's put this aside. And okay, these are the answers that Parker suggested, and this one was right, but these are actually subtle. Is this the possible chart? Or is this a possible chart? Now, they're all very similar. I won't do all 4 of them right now, but let's eliminate them one by one until we're left with the chart B. Well, if you look at it very carefully, it seems to imply that month 4 there was introduced, and there was. But this one implies that there was at month 10 there was a chip introduced, but this was really at month 9. So this is not the right answer. How about chart A? Well, they introduced a chip at month 5. Not true. It was month 4. This is not right. And likewise, chart C is not good. And the Goldilocks is chart B, where these introductions were at month 4, 9, 15, and 19. 4, 9, 15, and 19 seems to have done the trick. Now, it's clear that as you're looking at the chart, that every time they introduce a chip, the demand increases. So that's clearly part C is the right answer for the second part. Now develop a causal regression model. The word causal, by the way, is controversial. I won't get into that right now. It's never clear what's the cause and effect here, unless you do a controlled experiment or some other more advanced techniques. Anyway, they want you to introduce a model where you have 3 variables, namely the month and the new chip introduced. Let's open that in StatCrunch, my preference here. We're going to go to, now notice that the new chip introduced is not yes or no, it's 1 and 0, which makes our life easier. We don't have to translate it into 1s and 0s, which we would need if we were doing this numerically, which we are, but the book already has it for us. So go to Stat, Regression, Multiple Linear. We're trying to predict demand. We're going to use month and new chip introduced to compute it. And we see that both variables are significant. The coefficient is 3027. The month is 536, and the new chip introduced, that variable, is 4956. So that's why this second part is correct. So we don't need this anymore. We don't need it. Now the question is to make a forecast. Well, at month 25, you plug in a 25 here, multiply by this, and add on the intercept. But if a new chip is introduced, that variable, that is symbolized by a 1. So 1 times 4956 plus 25 times 536 plus 3027 comes out to, and here I have to get out my trusty calculator. It comes out to, well, I have the second one. I did this actually a few minutes ago. And this comes out to 16. Yeah. Nope, my mistake. I was typing into the wrong spot. Let's do it from scratch. So it's going to be 4956 0.9 times 1. Oh, good, that's the right order. First, let's do 25 month times 536.72 to 2 equals 13,418. Add on the 30. Next mistake. 536.722 equals. Add on the 3027.618 plus, and 4956 times 1 comes out to a grand total of $21,401.68, which they are cast around to the nearest whole number. 401 really is 402. Now, and it makes sense because when you're making a forecast, you really can't get it down to the nearest penny. That's ridiculous. And even the nearest $1,000 might be a good rounding. So to get the answer without, when it's not introduced, this is a 0. Well, 0 times this is 0, so it's going to be 4956.9 lower. So minus 4956.9 lower comes out 16,444. 1644, but since the cents is 76 cents, it's 445. Check answer. Oh no, what did I do wrong? I'm sure the answer is very close. I don't know, maybe some rounding. Let's check it again. I'll check. 21,403. Let's see. My answer is 402, so I round it. 445. How did I get 446? I'm going to have to try that again. Okay, I'm going to multiply. That'd be 536.722 times 25 equals 13,014.05. Add 4956.9. I think maybe I left out the 0.9. 4956.9 equals 25 times 536.722. Maybe this is why Excel might be easier. You can do this in Excel if you equals. Maybe that might be a good lesson. Plus 4956.9 plus the intercept is 3027.618 equals 21,403. What did I say? Oh, so I guess I think I left out that 0.9. It's just a matter of multiplication. All right, guys, that's it. Stop sharing.